So here we are on section 2 of our function review, and let's take a look at this graph. Is it continuous? Yes, it is, because I can trace my pencil along the whole thing. My domain in interval notation, everything from negative infinity to positive infinity is a possibility. I don't have any holes, and my arrows tell me it goes on in both directions forever. So guess what? My domain and range are all real numbers. So here's our conversations about where our graph is increasing. So each of these is our minimum, our local minimums and maximums. So we need to go back to having that conversation about our ant. If our ant is walking along this part of my graph, what's he doing? Yeah, he's decreasing. So from negative infinity all the way up to this x value here at -2, he's walking downhill. So what happens after that? What's his story then? Guess what? His story from here to here is that he's increasing. So from -2 up to -1, he's increasing. Guess what? He's not done, because here's his ant walk again, and he's back to decreasing. So we'll put a union of from, this is not -1, it's +1. From +1 all the way up to +1, 2, 3 is when he's decreasing. And then guess what? He starts going back up the hill when he's along this part. So from +3, 4, 5, 6. So from +3 to 6, he's increasing. And then finally, from +6 on to infinity is where he's then going down. Where is the interval constant? There is no interval. So an interval where it's constant is none. All right, so this is my input, is the function of an input of 5. 1, 2, 3, 4, 5. Is that f of 5 is my output. So when 5 goes in, 1, 2, 3, 4, 5, is my output positive or negative? My output is positive. As x approaches negative infinity, where's my graph going? Whoop, up to positive infinity. As x approaches positive infinity, where's my graph going? And here it's going to negative infinity. How often does the line y is equal to 3? Here it is, 1, 2, 3. How often does it intersect the graph? Let's see. 1, 2, 3, 4 times, because here it's at the maximum. So that y is equal to 3 is this horizontal line that goes through my graph like this. And how many times does it intersect it? 1, 2, 3, 4 times. All right, so let's take a look at this graph and see about some of this input-outputs. So make sure you talk to yourself, is this an input or an output situation? So when 0 goes in, 3 comes out. When 3 goes in, 0 comes out. When -2 goes in, -2 comes out. So this is 3 times f of 1. So that's 3 times, what is the output when the input is 1? 1, 2, 3, 4, 5. So 3 times 5 is 15. F of 3, or of -3. 1, 2, 3 goes in, 0 comes out. F of 5. 1, 2, 3, 4, 5. 5 goes in and 2 comes out. So 0 minus 2 is negative 2. If f of x, now this is my output, if 0 came out, now let's talk about all the places where 0 is my output. 1, 2, 3, 4. Those are all my solutions. So what was x? X was negative 1, 2, 3. X was negative 1. X was positive 1, 2, 3. And x was positive 4, 5, 6, 7. Anytime these x values went in, that's when a 0 came out. It's asking me what x's are going to make that possible. All right, so make sure you can see this. Is f of 1 greater than f of 4? Let's go to our graph. So when 1 goes in, 1, 2, 3, 4, 5 comes out. When 4 goes in, 1, 2, 3, 4, 1 comes out. So it's asking you, is 5 bigger than 1? Yes, that is true. Is f a function? Well, let's give it the vertical line test. Ready? It only intersects every point once, so guess what? Yes, it is a function. Now here come the local minimums and maximums at x is equal to each of these values. So my local maximum is going to be, here's this high point here, 1, 2, 3, 4, 5, and that happens when x has an input value of 1. Here's my next local maximum, and that's going to be at 3 when x has an input value of 1, 2, 3, 4, 5, 6. So you can see what that looks like on my paper. What are the local minimums? So let's look at these low points of the graph. Where are these points? So negative 2 is the output when x is at negative 2, and 0 is the output when x is equal to positive 3. So that's what these answers look like. Make sure you ask questions on what you don't understand.